Okay, welcome back now to derivability. Here we are going to take a look at cofunction identities in trigonometry. You may have seen my previous video on deriving the cosine difference identity, which I've sketched onto the screen for us already. Okay, if you want to, go back and watch that video to see where this comes from. Okay, also let me just give us a little reminder. Okay, some of you may not be familiar with this symbol here. Okay, that triple line equal sign means that two expressions are identical to each other. It's a stronger statement than just a plain equal sign, and it means that the two expressions are the same, no matter what the values of the variables on either side of the equation. Okay, it's not an equation to be solved for a variable. It's just always true. Okay. All right, so let's get started with this idea of cofunction identities. Okay, what I'm going to do here is I am just going to start by setting theta equal to pi over 2 radians on each side, or if you like, 90 degrees. Okay, and so what we get here is cosine of pi over 2 minus phi. Okay, well, this should be equal to the cosine of pi over 2 cosine phi plus the sine of pi over 2 times the sine of phi. Okay. All right, well, this helps because pi over 2, that's a specific number. The cosine of pi over 2 is equal to 0, so that just goes away. In fact, this entire term goes away. And the sine of pi over 2 is equal to 1. So without a lot of heavy lifting here, we're finding that the cosine of pi over 2 minus phi is identical to the sine of phi. Okay, and this is the first cofunction identity. Okay, in general, there are going to be 6 of them, basically one for each of your trigonometric functions. Okay. All right, now I'm not going to derive all 6 of them, but I am going to show you how you can get more if you follow some steps. Okay. All right, well, next, maybe we would like to get one involving maybe sine of pi over 2 minus some angle. Okay, so let's begin with this identity, and now let's put phi equal pi over 2 minus some other variable name. I'll choose the Greek letter alpha. Okay, now when we do that, we get cosine of pi over 2 minus parentheses pi over 2 minus alpha. This should be identical to the sine of pi over 2 minus alpha. Okay, now in terms of the parentheses inside of the cosine, if we distribute a negative through the parentheses, okay, our argument inside of the cosine is going to be pi over 2 minus pi over 2 and plus alpha. Well, we get those two fellers to cancel out with each other. And finally, what we find here is cosine alpha is identical to the sine of pi over 2 minus alpha. Okay, it's another cofunction identity. Now, you may wonder why they're called cofunction identities. Well, you may have noticed that our trig functions come in pairs. We have a function with a name like sine, and then another function which is the prefix co in front, cosine. Secant, cosecant, tangent, cotangent. Okay. Coincidence or conspiracy. Okay, well, it's not a conspiracy, but it's not a coincidence either. Okay, any pair of functions that are related by this co prefix, have a cofunction identity that relates them. Okay, so in some sense, those identities come in pairs as well. All right. Now let me clean up the board here just a little bit, and then we will continue. Okay, well now suppose we want to try to figure out a cofunction identity for tangent. Now you're probably going to guess, due to the pattern that you've seen in our video so far, or maybe before even watching our video, you're probably going to make a very educated and in fact correct guess that this is going to be the cotangent of theta. Okay, and that's correct. But how would you go about proving that? Okay, well, a lot of times proving things, you have to go from one step to the next in a very logical and justifiable manner, going from one step to another. So let's remember that no matter what else is true, tangent is always a sine divided by a cosine. Okay, but it has to be the sine and cosine of the same number, or at least the same argument here. Okay, so this is going to be the sine of pi over 2 minus theta over the cosine of pi over 2 minus theta. Now what we can do here is we can use cofunction identities on each of these. So the numerator, sine of pi over 2 minus theta, that's cosine. Downstairs, cosine of pi over 2 minus theta, that's sine. And then finally, cosine over sine is indeed the same thing as cotangent theta. Okay, so you don't have to assume that tangent pi over 2 minus theta is equivalent to cotangent theta. It can be proved using identities that we have already figured out, or we already know, we already believe. Okay, so what I would challenge you to do now is to see if you can use the cofunction identities for sine, cosine, and tangent that we have already proved to derive a cofunction identity for cotangent, for secant, and for cosecant. Okay, and again, these are more than just one-step sort of things where you assume that it is what it is based on the co-prefix pattern. Okay, you can actually use the steps that I've shown you previously in our video. Okay, all right, well, I think that's going to do it for now. Hope you've enjoyed this. Hopefully it's been a helpful thing for you. Okay, share this with your friends, classmates who are studying the same sort of thing that you are right now in trigonometry or some other course. Like, subscribe, leave me a comment. Love to hear from you. So thanks again for sticking around to the end, and thanks for watching on derivability.